Okay, for this one, we are after A, this guy right here, and our goal here takes 2 steps to do this problem, because before I can get A by itself, I have to get this whole thing by itself. In other words, this has to go. So since they're adding, we're going to subtract. So I have omega equals omega sub 0 plus AT, and I'm going to subtract the omega 0 from both sides. Now, in physics, get used to this, we use a lot of subscripts. They are not telling you to do anything mathematically. They are simply describing the quantity we're talking about. So in this case, even though they're both omega, the little sub-zero there denotes it as a different quantity. These happen to be angular speeds, how fast something's spinning. And just to give you a little background, this omega is how fast it's spinning later, and this one, sub-zero, is how fast it was spinning at the beginning. That's all that means. But the key here is that you can't just add them together. They're not the same thing, or subtract them in this case. All you can do is write omega minus omega sub 0. That's it. Equals AT. Notice, I rewrite the equal sign underneath. I rewrite my equation every single time. The faster you try to go, the more you're going to lose track, and things are going to be a problem. Next, now we can get the A by itself by getting rid of the T. And since the A and the T are being multiplied, we can divide both sides by T. Now here's the key. We divide everything on the other side by T. So that's going to leave us with omega minus omega sub 0 all over T equals acceleration. Now that is one way to look at it. You could, if you wanted, look at it as acceleration is equal to omega divided by T minus omega 0 divided by T. But the T would have to go under both, not just one of them. And that'll probably come up later and we'll talk about it. But this is, to me, a better way of writing it, a little more compact and makes more sense. All right, we're going to do the next one as well in this video. So we're solving for L. Well, in this case, it really is just like the previous problem. It just looks more complicated, but this really, it's a 2-step process, just like the last problem. I'm after L. I'll get all fancy here and see. Yeah, there we go. I am after L here. See, I highlighted it. So, the first thing I got to do is subtract that from both sides. So I'm going to rewrite it over here. I got S. Now I'm subtracting 2 pi r squared from both sides. So that means S minus 2 pi r squared equals 2 pi r L. So it's just like the previous problem. The thing that wasn't being multiplied times the variable that we're looking for, it gets added or subtracted to the other side. It doesn't matter that it's a longer expression and more things. We still just, boom, add it to, in this case, subtract it from both sides. Now, in the previous problem, we were, that's not what I wanted. There we go. This thing's going to go away. In the previous problem, we had to divide both sides by this T. Well, what do we have to divide by now? Anything and everything that is being multiplied times L. So all of that, 2 pi and r, are all being multiplied times L. So all at once, we are going to divide both sides. Remember what it means to divide both sides. So we're going to divide by 2 pi r. That means everything over here gets divided by 2 pi r. Which gets rid of the 2 pi r on the right by making everything 1, except the L. The L survives. So I have an L on the right here, and over here I have S minus 2 pi r squared, 2 pi r. Now, ladies and gentlemen, I cannot stress this next point enough. For the love of God, you cannot, because of this minus sign right here, because of that minus sign, here, we're going to just do this real quick. because I want to make sure that you guys don't fall into this mistake. Boom. Because of that minus sign, right there, you cannot just cancel the 2 and the pi and the r with this. All right, so let me just say this real clearly. What I am about to do inside this box is actually incorrect. This is wrong. I can't make this clear. This is when some of you will start to pay attention and start thinking this is the way you're supposed to do it. But it's worth it to show you that this is wrong. You cannot do this. So you cannot take the left side of that equation and say, all right, 2 pi r. Oh, wait, the 2 and the pi and one of the r's cancel out. And so that's just s minus r. Awesome! No! No, you can't do that. No, that is not allowed. The best you can do, if you want to cancel some stuff, is to put this under both of these. You can write s over 2 pi r minus 2 pi r squared over 2 pi r. You can do that, and that would allow you to cancel this portion of it right here. Here, instead of doing that, let me do it this way. I can simplify this now. But see, notice that's different than what I have over here. The s never dealt with what should have been underneath of it. So, whoa, I love that. That's so much fun. Sorry, I'm distracted. I'm back. All right, so we can simplify this a little bit. I can go s over 2 pi r, that has to stay, minus, and these will cancel, except there'll be just 1 r left over. This is fine. So is this original answer that we had. Either one is fine with me. There may be certain situations where you want it one way, one at the other, but both are perfectly fine. They don't look an awful lot alike on first glance, so I can see if the book wrote the answer this way or something, or somebody wrote the answer that way, you might think you got the wrong answer if you had it this way, but you don't. They're both fine. My advice is, I would rather you not simplify. I would rather you not simplify anything because it's so easy to do it wrong. So if you had this and you thought you were being clever and you turned it into this, you would have completely ruined everything. So when in doubt, leave it unsimplified, particularly in a physics class. We can afford to do that. All right. Here endeth this video.